Okay, today we're going to take a look at the fundamental counting principle. This is chapter 10, topic 1. Fundamental counting principle says if one event can occur in ways, a second event can occur in ways, then the number of ways both can occur is m times n ways. And this can be extended to more than two events, multiple events. So let's take a look at this. The school cafeteria offers a choice of two main courses, grilled cheese or soup, and five desserts, Jell-O pudding, fruit cup sundaes, or granola bars. How many different lunches could you have? All right, so first we have to think about what are the different events here. You can think of events as being choices or, yeah, choices. So the different events here we have is we have event one, which is the main course. And then we have event two, or choice two, which is the dessert. Now, each of these events has different options, okay? So, event one, which is the main course, has two options. It has the grilled cheese, or it has the soup. Now, for each of these event ones, they can be paired with five different options for dessert. Could be Jell-O, pudding, fruit cup, sundae, or granola bars. Okay, so that's event two, and those are the five different options for event two. Now that's five options for event two paired with event one, with one of the options from event one. What about the other option? Well, if you get soup, you also have those five options, Jell-O, pudding, fruit cup, sundae, or granola. So in total, if I want to know how many options I have, every option for event one paired with every option for event two, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Now the way to do this using the fundamental counting principle is just to multiply the number of choices for event one, or number of options for event one, which there's two options, times the number of options for event two. There's five options. So 2 times 5, there are 10 possible combinations or 10 possible options. So how many different lunches could you have? There's 10 different lunches you could have in this case. Now this can be extended to more than two events. This could be extended to as many events as you want. So for number 2, you can have vanilla, chocolate, or strawberry ice cream at the store. There are 4 different types of toppings. You can also eat it in a bowl or a cone. How many different possibilities do you have? So first think about the different events. The events are what you have options for, okay? So for instance, we see that I have 3 different options here, vanilla, chocolate, or strawberry. Those go with a single event, event 1. And the first event here would be the type. You have the type of ice cream. And for the type, you have 3 different options. Event 2 would be, where do we have our other options? Well, here's our other options. There are 4 different types of toppings. So I have 4 options for my toppings, which is event 2. And then for event 3, I have another choice that I can have. You can also eat it in a bowl or on a cone. So that would be the, I don't know, method of delivery. We'll call it the method. And for the method of delivery, how you're going to eat it, you have either a bowl or a cone. So you have two options. So the total number of possibilities, how many different possibilities you have, would be 3 times 4 times 2, which is 24. There's 24 possibilities. Now, if you visualize this like we did the last one, you can think of it this way. Event 1 has 3 choices: vanilla, chocolate, or strawberry. Event 2 has 4 toppings. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And event 3, which is the delivery method for each one of those flavors, with each one of those toppings, you now have the choice of bowl or cone. Bowl or cone, bowl or cone, bowl or cone. Same for these ones, bowl or cone, bowl or cone. And if you count how many different possibilities there are with each one combined, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 different options. Okay, and that's what we got when we did it using the fundamental counting principle. Now, sometimes it's not easy to understand what the event that's occurring is. Okay, so whenever you're trying to figure out what the event is that's occurring, think of the options you have, and then try to figure out what event do those options go with. So number 3, you are asked for a password containing 3 letters followed by 2 digits. Okay, so like numbers. How many passwords can be created if repetition of the letters is A, allowed, B, not allowed? So first we have to think of the events. What events are happening here? Okay. Well, in order to discover the events that are happening here, let me think of the options. It says you are asked for a password containing 3 letters followed by 2 digits. Well, I have a couple of different options. So I have options for letters and I have options for digits. Well, what do those options go with? They go with the password. Specifically, they go with the placement of each letter or digit in the password. So my options here would be, or my events, the first event would be the first part of the first thing in the password, the first letter of the password. The second event would be the second letter of the password. The third event would be the third letter of the password. Fourth event is the fourth, and the fifth event is the fifth part of the password. So it says, remember, it says how many passwords can be created if repetitions of letters and digits is allowed. Okay, so the first 3 parts of the password are going to be letters. So how many options do I have for the first letter in the password? Well, there's 26 letters in the alphabet, so I have 26 options. The second letter is also going to be a letter, so I have 26 options there. And the third one will also be a letter, so I have 26 options there. Now the next 2 are supposed to be digits, numbers, 0 through 9. So there's 10 options for this digit, and there's 10 options for this digit. So I can multiply all of these together, and I will get the number of possible passwords, which is 1,775,600. Now, this is if repetition is allowed, okay? So the letter that I'm using in the first code of the password could be the same letter in the second one. But what about if repetition is not allowed? So if repetition is not allowed, the first part of the password, the first digit in the password needs to be a letter. Okay, so I have 26 choices, 26 options. However, the next one needs to be a letter, but it needs to be a letter I haven't already used yet. Well, I've already used one of the letters, so I only have 25 options left because one of them was already used. And the next one, I've already used a letter here and I've used a letter here, so I only have 24 options left because I've already used one in each of these. This one needs to be a number. Well, I have 10 options. If I don't want to repeat the same number here, then I'm only going to have 9 options for this one. So the total number of possibilities without repetition would be to multiply these all together, so 1,404,000. Quite a bit less, a couple 100,000 less options. Whoops, this should be number 4. A family is taking a photo. There are 8 family members. The mother and father want to stand on each end. The 6 kids are in the middle. How many ways can they stand together? Okay, so when we think about this, we first want to think about what are the options? Well, the options are the family members. They can stand in certain places. So the event is going to be where they're standing. They can either stand in the first spot, they could stand in the second spot, could stand in the third spot, the fourth spot, the fifth spot, the sixth spot, the seventh spot, or the eighth spot. For each spot, there's going to be different options. So for the first spot, well, remember, the parents are standing on the ends, and all the kids are in between. So in this first spot here, there's only 2 choices. It's either mom or it's dad. In this spot, it's one of the kids. So there's 6 kids to choose from, 6 different options. This spot is also a kid, but it can't be the same kid in this spot. So there's only 5 options here. And there's a kid here. There's only 4 kids left to choose from. There's a kid here. There's only 3 kids left to choose from. There's a kid here. There's only 2 left to choose from. And the last kid will go here. And then in the last box here, well, remember this needs to be either mom or dad. We already used one of them on this end. So there's only one left. It's either mom or it's dad. So the different number of ways that they could stand together, 2 times 6 times 5 times 4 times 3 times 2 times 1 times 1, 1,440. Now, a little introduction to the next lesson, permutations. A permutation, and this kind of has to do with the fundamental counting principle, it's an arrangement of items in a particular order. Okay, it tells you how you can order a list of things, okay? And one of the operations we use when we're doing these is a factorial. A factorial is an exclamation mark. And essentially what it does is it says take that number and multiply it by every number that comes before it. So n factorial, if n were 5 factorial, then 5 factorial would be 5 times 4 times 3 times 2 times 1. It's the number 5 multiplied by every number that comes before it. And this will be in your calculator. There is a factorial button in your calculator. Sometimes it's under the probability function, and sometimes it's not. Okay, sometimes it's just an exclamation point. And this will tell you how many ways you can order something, because it essentially works just like a choice. Okay, so like for instance, in how many ways can 6 trophies be arranged on a shelf? Well, there's 6 options for the first place on the shelf. There's 5 options for the second place on the shelf. There's 4 options for the next place on the shelf. So If we want to know how many ways 6 trophies can be ordered, that is ordering of items, that's a permutation. So we do 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Or we actually do that 720. Okay, very easy. And how many ways can 8 students line up? There's 8 choices for the first place in line, 7 choices for the next, so it's just 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, it basically just uses the fundamental counting principle, which is 40,320. Okay, so if you have a problem asking you how is something ordered, is ordered like this, okay, using factorial. All right, the assignment for this is a worksheet that is on Canvas.